Hi and welcome to this third Syntex web test system video. Today we are going to show you how you can achieve optical characterization with large dynamic range using STS-PDL. Plus, we will present you our new WDM analysis tool that will make your CWDM and DWDM characterization gain in efficiency. For this demonstration, we are going to use a 4-channel CWDM device with a first channel centered at 1530 nanometer and channel spacing of 20 nanometer. In a similar way as we have seen in previous videos, we are going to measure reference data first. But this time, because our device has 1 input and 4 outputs, we have to select all channels on our MPM. Then click Set. Also, because of multiple outputs, reference data will be recorded using single ref. By doing so, we will have to select each channel, seen here in green, and connect it. Then record its reference spectrum. Once the sweep is done, we select and connect the next channel and collect its reference spectrum, and so on. At this point, everything is ready to start measuring CWDM device. But to show the large dynamic range of our swept test system, we are going to introduce one of our new features, measurement range selection. This feature, present on our STS-PDL software, allows you to select the suitable measurement range on MPM power meter, and thus, you will have the control over the dynamic range you need to characterize your devices. So, as we see here, to access this feature, just click on Setting, then Measurement Range. This window appears, and the first thing we notice are these large yellow squares where MPM specifications are reported. Now, depending on APM model, we have some differences on dynamic range. In this video, we are working with Syntex MPM 210, so let's take a look at the specs. Each range has a span of 40 dBm, and the highest power of each range is 10 dBm higher from the next range. So, using range 1, the dynamic range will be from plus 10 to minus 30 dBm. For range 2, it will be from 0 to minus 40 dBm, and so on. We can select the desired range from central column, and from this box we can select how many times the system will sweep through different ranges. Let's see how it works. At first, we will keep the range at default value. So let's click Set and start wavelength sweep by clicking on PDL measurement. We can see after scan completion that the insertion loss dynamic range is from 0 to minus 40 dB. Notice that the software has also completed PDL calculation and now displayed on the lower graph. Let's go back to measurement range window and select 2 scan times. Let's keep the first scan at first range, while setting the second scan at range 4. Now we close this window by clicking on Set and run the scan again. And here we can see that the dynamic range is from 0 to -70 dB. So, thanks to our measurement range setting, we are able to get large dynamic range efficiently while keeping short measurement time. Now that we are here, let me have some words on another analysis tool in STS-PDL software. Earlier, we saw simple analysis tool. Now, we get to learn about WDM analysis. By clicking on WDM analysis window will appear, and first thing displayed is IL spectra. To set analysis parameters, we just click on Parameter Setting tab. We've seen at the beginning of this section that our CWDM is composed of 4 channels, 1530 being the first center wavelength, and the spacing between channels is 20 nanometer. So we input these values in corresponding boxes. Next parameter to input is the threshold for central wavelength detection. This threshold is set in regards to maximum measured insertion loss. In this example, let's fix at 3 dB down. For the passband parameter, we are looking at a range of wavelengths around central wavelength to calculate ripples. For this demonstration, we will set passband at 3 nanometer. The great advantage of STS-PDL software is that you will be able to calculate the bandwidth of each channel at 3 different levels. For example, we will measure the bandwidth at 1, 6, and 20 dB down. The final parameter is the range of wavelengths to estimate isolation band, that is, the difference between the maximum insertion loss within the filter passband and the minimum loss occurring within the other filtering passbands. So here, for example, we will set this band as wide as the passband. Now that all parameters are entered, we click on Set to save these parameters and move to the last tab on this window. On WDM Result tab, calculation results for all measured channels are summarized. So respectively are listed calculated central wavelength, the offset between theoretical and calculated central wavelength, estimated maximum and minimum insertion loss at central wavelength, and the next column will display the calculated ripple followed by the maximum calculated PDL. Bandwidths at previously entered 3 levels, here namely 1, 6 and 20 dB down, are shown in these columns. The last 3 columns are related to isolation, so first adjacent channel isolation, then non-adjacent channel isolation, and finally the total isolation. At any moment, analysis parameter can be changed by going back to Parameter Setting tab, change the values, then clicking on Set. Once back on Result tab, we have to click Analyze button to refresh the results. Analysis results can be saved by clicking on Save and choosing the folder for the CSV file. Now we are coming to the end of this demonstration. We hope that you are convinced that STS-PDL by Santec is the right tool you need to achieve large dynamic range characterization without losing time on measurement and analysis. On the next video, we will talk about STS-PDL speed and show you how you can characterize ITO grid with high precision in very short time.